If you feel really stuck, but you really want to use this technology, we have many AMD partners that can give you design assistance. And all three of these partners today on this call have that experience and capability to do that. And with that, I will turn it over to my friend Flemming from Sundance. He is the founder and the CEO. Flemming will be followed by Arnie with Semitown, who is the Chief Marketing Officer for Semitown. And then our last presenter will be Adam Taylor, who is the founder and CEO and principal consultant of Adiuvo Engineering and Training. Thank you for your time, and I'll turn it over to Flemming.
Hey, afternoon, morning. Thank you very much, Bryan. So I'm Flemming Christensen, and I'm the CEO or Managing Director, as we call them in the United Kingdom, where I'm based. And I'll be running through an example of a module which we designed some years ago. We call it the smallest single-wall computer with a Zynq MPSoC, and I still stand with that. We are long-standing sort of AMD or Xilinx sort of partner, and we value that partnership a lot. So Sundance is it's a fairly small little company, but about 11 of us. Been around a little while. We've got 5 people who are sort of fully trained by AMD's partner program, and we have always, since the beginning of time, designed and built our own products in-house. And we run a ISO quality system to reassure that we're doing what we're supposed to do. So the first time we did an FPGA module was back in '93, and that had one of the very early FPGAs and application for this was ironically doing some video processing, and here we are in 26, and that's what we're still using FPGAs for. So we were approached by a customer who was using an UltraScale 96, which do have an MPSoC integrated, and the objective and the request was that we needed to make it smaller and we needed to take less power. So we evaluated the options of picking the right processor for that. So on the Ultra 96, there's a much larger FPGA, and we realized to get it as small as 35 by 50 millimeter, which was the requirement. Then we had to either look at the chip scales or maybe going for the input package. And I really like the input package. Part of that reason is the size of it, but also that we have the options of getting a lot of pins on a small footprint. So the little picture of 1.5 watts, that's actually running a memory test. So it doesn't take a lot of power, and we managed to get that going, fairly quickly. So the objective was to get as much on as possible. I mean, this is what engineers do. They try and put everything they can think of. So it's everything. It's got its memory, it's got flash, it's got an IMU, it's got CAN, and it's got some general purpose IO, and then it's got MIPI camera interfaces, which have a dual purpose. There may be MIPI camera connectors, but that's more choice because they're so small. They're also just IO pins for the FPGA. So the rear side of it is it's not as busy as the top. We utilize Pongo pins, as they're called, to get connectivity if you want to add another board. So they're kind of breakout pins. The most annoying part of this board, which I hate with a vengeance, I hated it from the beginning, is the JTAG header. And it's as you can see, it's a very small header if you're familiar with JTAG on any FPGA boards, but it has to be there, and we obviously had to fit it as well. The block diagram is busy, and another benefit you have with using very small FPGAs is that you have signal integrity problems, but the board then distance to the memory is so small that you don't get long traces on it. So you have to be careful when you do the PCB design and routing, but you get very, very short distance on it. So we've had no problems at all running the memory at full speed without really any hassles at all. It just kind of worked. We ended up developing a number of breakout systems and development kits. So this was one of the first one where we had a number of I/O pins coming out of it, and it was just running out of the block and JTAG, etc., etc. And then we also developed what we called a 3D kit. So the initial request was to be able to make a 3D camera system, and some of you will be aware of where they are typically used, drone and such like, and it had to be obviously as small as possible. Well, what I didn't realize until we got this going was actually the benefit of having a 3D camera is if you can make the two lenses as close to one another, then the better. So that this is why we have this limitation of having to be a very, very small design. So this is a kit which we're offering. It's available, and we've got demo codes and source codes, and everything else is shared with customers. We also had a request to do a little stack, so we called it a stack, obviously, and it was just to. It's all very well having a small PCB, but if you want to connect a USB which for some applications, then we develop a little stack of where we add everything up. And ironically, on this board as well, there's a Raspberry Pi, which is the controller as well, that's sitting in between it. All the information about these boards are obviously available in the notes and also on the website and the QR code that we've got as well. The product offering we were doing, so we're offering just what we call the core product. It's just the product without any consideration for heat or anything else, and that's a product which is shipping now, and it can be customized to offer more memory. So there's two options: either little memory or a little bit more memory, but typically it's a 2 GB of memory to it. So one of the things which obviously happens with these small packages, yes, they only take 1.5 watts, but they do get very hot. And we then made some examples of what could be done. We'd either have a passive, an airflow running over. So we did a little heat sink example, and it's still done in plastic because we just needed to encapsulate it. So this is a plastic heat sink, and the weight of this little unit is about 26 grams. So it doesn't take a lot of power, and the fan will keep it cool. The same concept, the same design, just done with a 3D metal 3D printer, literally, and then we can keep it cool without having a fan. The weight goes up, as you can see, about 46 grams. So on the issue of getting hot, so our initial issues was how to get rid of the heat without the fan or without a massive heat sink, and it is simply just not possible. And it's one of the considerations you have to do with any small form factor boards or the FPGAs. They do get hot. What we also did. And we can run a little demo of that. Well, one of the issues, and Arnie will cover this as well, is the vibration of these things. So we decided to use Arnie's underfill capabilities, and we set up a little lab experiment of getting them shake a lot. And this rack, I won't even call it a rack. This is a denture testing bed. We use that for leaving it running for days and days and days, and we have absolutely no problems with it whatsoever. In terms of application stories, so we have made some commitments to other third parties of AMD. And one of the applications which is quite interesting is one Computer2. They have integrated a compression technology inside an FPGA. If you are familiar with Zynq FPGAs, then you will know that the ZUs3 do not have any built-in compression or decoder encoders. So that's what they've done, and that's a working example. And PLC2 offer a core that is targeted towards the VCS3. And another one of AMD's partner, they have interfaced a ProSyn event camera. It's a new kind of camera technology, which is very, very suited for running on the PCA. because it reduces the number of data coming into it, and then you can end up doing some CNNs and any kind of edge processing. We also work closely with the FPGA server, and it's Andrew Wilson, and he's developed some application storage and tutorial support, and he will go through all the various blocks on the VCS3, and he will make different tutorials of how to interface them and how to get them going. And his next event is it's next week, so you can register for that. And it's about an hour's tutorial, and it's obviously going to be stored and kept online. He has done 2 already, which cover sort of booting processes and also how to use it as a processing pipeline. So that's about it from me, and my last word is that we can obviously make any size of board you would like, because that's what we do. And over to Arnie.
Thank you, Flemming. Okay, good morning, good afternoon.